we now learn how to do some math, arithmetic with matrices. First of all, addition and subtraction. To add or subtract matrices, you just add or subtract the corresponding entries or corresponding elements. Now, something that becomes important, you can only add matrices if they have the same size. So if you're trying to add two matrices that are different sizes, they don't have corresponding elements, and then it's just not allowed. So if I had this square matrix, which is the 3 by 3, and the plus another square matrix, which is the 3 by 3, I can just add top row 1, column 1, 1 plus 0, I'm going to get 1. 3 plus 0, I'm going to get 3. 1 plus 5, I'm going to get 6. And so we can add a matrix together by adding the corresponding elements. And from a level from 1 to difficult, what do you think about adding and subtracting? Is that about 1? Not too difficult? Pretty straightforward. We can also have scalar multiplication. You have some number in front of a matrix. Well, then that number multiplies every single element. It's sort of like it gets distributed to everything. So if I had 2 times this matrix, I could get my answer by multiplying each element by 2. So I'd get 2, 16, negative 6, 8, negative 4, 10. And everything is straightforward. Matrix, adding and subtracting, super easy. Matrix, multiplying by a number in front, super easy. So for this next part, we're going to do an activity. Adding and subtracting is so easy that you would have figured it out right away. Multiplying by a number in front is so easy that you would have figured it out right away. But now we're going to look at A, B, C, D, and E, and we're going to multiply them. And right now, for the first part, we're going to use our calculators to multiply them and see what the answers are. And our job is to try and figure out 2 things. A, when are you allowed to multiply? Because a bunch of them you're going to get errors. And 2, how do you multiply? Look for patterns and see if you can figure out the rules for multiplication by testing things with your graphing calculator. So first of all, who doesn't have a calculator? I'll lend you one. Most of you have found a way to type in a matrix. There's 2 places where matrices come up on your calculator. 1, your alpha menu, if you go over to matrix, lets you type in a matrix. 1, 2, 3, 5. That lets you type in a matrix, but if you try to keep that, if we want to call that matrix A, you might run into problems because you might say, oh, I'd like to store this as A, but it didn't work. Quit. So another place to do matrices is if you look above your x to the minus 1, you see that it says matrix. If you go second matrix there, it has a bunch of matrices available for you to name. And so matrix A, I can go over to edit and push enter, and I can type in matrix A. Now, how big was our matrix A? The 2 by 3, 2 rows, 3 columns, and we can type in the numbers 1, 2, 3, 4, 5, 6, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. And now that's remembered as matrix A. So if I go into my main screen, and I hit go to matrix again, when I see A, it's listed as a 2 by 3 matrix. Now if I push enter on that, A comes up with brackets, and my calculator's remembering it's 1, 2, 3, 4, 5, 6. So I'd like you to enter in B, C, D, and E as well. So I'm going to put in matrix B, go over to edit, matrix B. Matrix B is a 3 by 2. One zero negative 1 0 3 2 1 0 negative 1 0 3 2. So we've got matrix A and we got matrix B. So once we've listed them all in, there's some math here for you to figure out. What's A times B? What's D times B? What's C squared? So go to second and then matrix, and then edit, and then push enter on A, and then you can make it a 2 by 3 and put the numbers in. So once you have them all typed in, you go back to your calculator, and if you wanted to do A times B, you can go second matrix, choose A, then go times second matrix, and choose B. And if we do A times B, we get 8, 6, 17, 12. So write that down, because later I'm going to get you to do, you know, your times table, so this shouldn't be too hard. Look at A, look at B. If you multiply them, does that make sense, the answer that we get? How do we get that answer? Okay, obviously probably one example won't be enough to figure out this puzzle. You multiplied two matrices together, A and B, and you got 8, 6, 17, 12. So multiply a bunch more together, see the answers you get. So our answers up till now, D times B, that one was possible, C squared. Wait for it. Never mind. E times B, there we go. B times A. B times D was not possible. A squared is not possible. But C squared is possible. There it is. Why is A squared not possible, but C squared is possible? What about B squared? Is it possible? What about E squared? What about D squared? One of them is possible, the other two aren't. So you can play around with more math if you'd like. You can get more data. But our job is to figure out when things are possible and when they're not. And then once you've figured out when they're possible, so many things. We have to figure this matrix multiplication out. So the idea that's come up is that the size and order of the questions matters. So if we look at one of these, E times B, there's E, there's B. Here's your order above E, here's your order above B, and there's your answer, which I'm going to call F. How do we tell how big the answer is going to be? How do we tell whether it's possible or not? Write out the orders of other ones that worked and see if you can find a pattern. And then write out the orders of ones that didn't work and see if you can see what's different about them. So to recap so far, we have used the order to figure out how big the answer is. We figured out that the outside numbers were the size of the answer when it works. But we haven't figured out yet when it works and when it doesn't. C times A. So if we try that one, C times A, okay, C is a 2 times 2, and A is a 2 times 3. And this one you said works, and so the answer is a 2 by 3. Using our outside numbers strategy that Eric came up with that seems to work every single time. But we haven't figured out when it works and when it doesn't. One, two, three, four. I'm going to write C out. Oops, go back. This was C times A and we know that since this one is a 2 by 2 and this one is a 2 by 3, that our answer, which works, is a 2 by 3. But we haven't figured out why it works and how we can tell that it works. But I'm going to circle this 2 by 3 and this 3 and this 2 because we figured that out so far. Figure out if it works, how big the answer is going to be. But we haven't figured out when it works and when it doesn't. Go back to our previous one here. Click our results so far. So these are the examples you have so far. Okay? I'm going to, without using numbers, give you some more examples. If I multiply a 2 by 4 by a 4 by 1, it works. It gives me an answer that is a 2 by 1. If I multiply a 3 by 5 by a 2 by 7, it doesn't work. But a 3 by 5 multiplied by a 5 by 7 does work. You give me an answer that's a 3 by 7. If I multiplied a 3 by 5 by a 5 by 1, it works. It would give me an answer that's a 3 by 1. But if I multiply a 7 by 7 by a 5 by 5, it doesn't work. But if I multiply a 7 by 7 by a 7 by 201, it does work and gives me an answer that's a 7 by 201. What has to happen for them to work? Yes. Okay. Look at the ones that have worked. The columns of the first one match the rows of the second one. And the answer is this size. So now we know when they work and when they don't. The next question is, can you see that this one will work? The inside two numbers are both 2's. How can I do this in my head? 9. The next one is 12. 15. 19. 26. 33. I had to do some thinking, though. You notice that I didn't just go super fast. Where did those numbers come from? How do we get them? That's our next job. One, 5, -2, 3, -7, 8, -6 equals, again, this is the right sizes. We should get a 2 by 3 as an answer because our size is 2 by 2 times by a 2 by 3, so we should get a 2 by 3. And if I put these together, I'm going to get -2, 6, -3, -2, 6, -3.